So another normal distribution question. Cars, one of my favourite subjects. And this time we're using the normal distribution and the inverse normal distribution. So as with any other normal distribution question, and many other types of question as well, my inclination is to draw a little diagram. So X is the probability distribution for the lengths of cars in the UK. We're told that the mean is 3.54 and the standard deviation is 51. So putting that information on now. To get the scale on this, I'm saying that that point there is the mean plus 3 standard deviations. That is the mean minus 3 standard deviations. So that's what those figures are there. It gives me an idea of the scale. And we're trying to find the proportion of the cars in the UK that have a length between 2.5 and 3. So 2.5 is something like that, and 3 is something like that. So we're looking for that area there. Using our calculators, putting a lower figure of 2.5 and upper of 3, standard deviation of 0.51 and mean of 3.54, we should get a figure of 12.41% or 0.1241. So that's part A. Now part B is a slightly different question. We're saying what length do only 5% of cars exceed? So we've got a length here and we've got 5%, just 5% of cars exceeding that length. So in order to do this one, we need to use the inverse normal distribution. And depending on what calculator you have, the calculator might just ask you to type in the area, but it also, there are other types of calculators which ask you about the tail. If you've got the calculator which asks you just for the area, then that will be the area to the left of the L, which would be 0.95. But if you are allowed to put in the tail, you could put the area of 0.05 and the right tail. So you've got those two choices depending on what calculator you have. The calculator that I've used just asked me to put in the area, so I put in 0.95 with the standard deviation and the mean, and I got a figure of 4.38 for L. And the advantage of drawing the diagram is I can look at that and say, yeah, 4.38 looks about right, closer to 5.07 than it is to 3.54. Okay, so part C now, we're talking not about a single car being chosen from all the cars in the UK. We're now talking about a sample of 30 cars. So this is a different probability distribution. We're looking at the, we're going to call this probability distribution Y, and Y is the number of cars from a sample of 30 which have got a length between 2.5 and 3 meters. So that is a completely different distribution to the distribution we've been looking at. So because we're talking about the number of cars, this is a binomial distribution, and we've got a number of trials of 30, and we know what the probability of a single car from the sample being between 2.5 and 3, that's 0.1241. So the probability distribution of Y is that. And we're trying to find the probability that more than 5. So that's the probability that y is more than 5. And my calculator, I would have to find the probability of y being less than or equal to 5 using my cumulative probability distribution for the binomial. And that gives me 0.8395, which I have to subtract from 1 to give me the final answer.